how many of you have been able to join? I would like to know how many persons here can hear me. Like you can hear me now and you can see my screen. Please indicate. You can hear me and you can see my screen. Okay, so from our previous training, um, if you have any question, I did like you to drop those questions in the comment section and it's going to be attended to. So in today's class, we will be carrying out simulations with Spe Hysys. Yesterday's class was basically an introduction to Spe Hysys. We talked about what Spe Hysys is used for, um, different applications of Spe Hysys. So in today's session, we are going to move from just the theoretical aspect of what analysis is, how is it being used, what is being used for, to practical examples. We would now, carry out real life simulations with Aspen Hysys, which I believe we all are good to go. Yeah, I believe we all are good to go. So in today's class, we are going to look at we are going to start with basic examples like mixing two streams. In our previous class, we looked about the interface of Aspen Hysys. We got to that point or extent. I also added a feed stream. I think I'm going to share that slide again, or that session. So basically, I told you about the different color sign. This light blue, it means this stream has not been fully specified. You have not yet given Aspen Hysys um, the required information to carry out its calculation. Yeah, we talked about the model palette and few other things. So in today's class, we are now going to be looking at a real simulation. So I'm going to close this case study, close case. No, I don't want to save. Okay, now example one, we want to blend two streams, and these streams, one is water. Okay, we want to blend two water streams, and the first stream has a, the first stream has a temperature of um, we want to blend these two streams. One has a temperature of 30 The other one has a temperature of 80. Yeah. Now, we want to determine the temperature of the mixed stream. And the component we are working with is water. So you can see it here. Two water stream, two water streams. Okay. What was given, our temperature was given, um, the mass flow was given. We are also going to impute pressure. Pressure is 1 bar. Yeah, pressure is 1 bar. Now, the first thing we need to do is to move to our Spe Hysys and, take the step-by-step approach which I taught yesterday. I'll open a new case. Okay. Just give it a minute as Spe Hysys is loading. Sometimes it takes a little bit time. Now, please, if you are online and you can hear me, you can see my screen, kindly indicate in the chat section. Okay, now we have our component list. I'm going to click on add. Then from the search tab, I will type water. You can see H2O here. Or click on add. For this, the fluid package we will use is Pen Robinson. We're still going to use Pen Robinson. Now, someone asked in our previous class, why, please explain why we are using Pen Robinson. I said, thermodynamic model is a session on its own. If we include it, it's going to be a 3-day session. So we are going to treat thermodynamic model in the paid class. Why are we using Pen Robinson? Why are we using water? Why are we using Uniquark? Why are we using this fluid package we are using? Okay, so for that, we are going to use water. Yeah, this is it. Click on the fluid package and search for Pen Robinson. Scroll down, click on it, Pen Robinson. I'm done with that. The next thing I'm going to do is to switch over to my simulation window. Click on simulation, and here I am. Now, question says we are mixing two streams. So I'm going to click on my stream one, the stream one, double click on it, and I will call this stream one. Okay. I'll come to compositions. We have just one component here, which is water. Click on edit and use one, because this our composition basis is a mole fraction. I know mole fraction, the mole fraction basically is a fraction which is 0 0.1, 0 0.1. The total, when you add all the mole fraction of the components, it's supposed to give you 1. Yeah. So for this, we just have only water, so it's going to be just water. So we have just water. Okay, so our temperature is the temperature we have is 30 degrees C and 5 kilogram per second, which I would impute here. For the temperature, we have 30 degrees C, and our pressure is 1 bar, type 1. Click here, look for 1 bar is one bar. Now you can see that Spe Hysys has automatically calculated some some of these, but we can see at the bottom is giving us an error on no flow rate, and the flow rate is kilogram per second, 5 kilogram per second. Click on 5, switch to kilogram per second. Now, if you look at the bottom, it is saying okay, indicating that you have fully specified this stream. And you can see that it is now what? It is now blue, no longer, um, it is now thick blue or navy blue, not that light blue it was before. Okay, now we are going to add the second stream. The second stream is water, still water, but at different temperature. And so the temperature of this is what? 80 and 10 kilogram per second. We have 80, ten kilogram per second. Okay. Then we come to composition. I'll do the same thing. Click on edit. One whole number. Now you can see I haven't specified pressure. So Spe Hysys is giving me that warning that unknown pressure. So I'll come here, type 1 bar. Yeah, fully specified. You can see that the two streams are fully specified. I believe you all are following up to this point. Very easy. Then the next thing we need to do is to add our mixer. Now this is our mixer. Our mixer is mixing these two streams. We are going to have the last stream, which is mixed out. Okay. You can see that this mix out is light blue because as far as we haven't specified anything, but we are not going to specify anything. What we need to do, our question says we should calculate the temperature. Our question says we should calculate the temperature. So, and you can see our mixer here is what is red, meaning the streams required at the attachment required for it to solve has not been given. So I'll double click on it. Stream 1, I'll click on stream 1. You can see that it has it has entered, but it has not still solved. I'm going to also click on stream 2. You can see that it has entered. If I close this, it still doesn't change, still color red. Now I'm going to click on out. It says okay. That's calculated. Now remember, we didn't specify anything for this. Our mix out, we didn't do anything. And our question says, calculate the temperature or determine the temperature of the outlet stream. Now let us look at what is the temperature. I'm going to click on this mix out, right click, show table. Now this is what we have. You can see the temperature of the mixed out. This is 146.1. I'm going to change this to SI unit. So you can see that this is 63.69 degrees Celsius. Let's check this show table. So what entered here was 30. What entered here was 83. After it was mixed, we had a temperature of 63.39. Please, I would like you to remember the 63.39. We have pressure of 100 kilopascal. Now you can see the molar flow 1998992. But here it has changed also. So I believe you all are following me. So if you have followed me to, if you understood up to this point, please indicate in the comment section. Okay, so you guys are following. That's good. So for this one now, you can see that everything has been calculated very well. Then we are going to look at another example. We are going to look at another example. Now, in this example, we will be looking at a splitter. So this now, a water stream of 100 kilogram per hour at 60 degrees C is split into two equal parts. Verify that the outlet streams have the same property as the inlet streams. Okay. Okay. Now this is a good one. I believe you all understood question. So instead of we doing this same thing again, so what I'm going to do, I'm just going to add instead of we doing the same thing all over again, what I'm going to do basically is to add a splitter. Now, this is the splitter here. It's called a T. I'm going to add it here. I'm going to add it here. I would add another stream. I would add another stream. Now, now these two streams, our question says it needs to be split into two equal parts. Now, I'm going to add my inlet stream, which is the mixed out, and I'll add just one outlet stream, one. You can see it's calculated. Okay, I just added one outlet stream. Now, the moment I add the other outlet stream, making it two, you can see unknown split fraction. Remember, our question says this T or splitter will split this into two equal parts, 50-50. So now this is where we need to impute the split fraction. Tell Spe Hysys that, okay, this is going to, you are going to split 50% to terminal A. So let's assume that this point A is a terminal. I'm going to do this terminal A. We'll name this as terminal B. Okay, so we want 50% of our flow to go to terminal A and 50% of our flow to go to terminal B. How do we do that? We double click on the T, come to parameters, get. Now, these parameters, we have just 1 degree of freedom. So when we say 1 degree of freedom, what does it mean? It means you just need, if you specify one of these two parameters, Spe Hysys is going to calculate the other one. Now, how you know the degree of freedom is, the degree of freedom is the required streams, the required inputs, which is the required number of inputs minus 1 is your degree of freedom, which is what you need to specify. So for this, I have um, two fields I need to specify, which is m minus 1 will give you 1. So for this, I'm just going to type 0.5 and hit enter. It automatically, Spe Hysys automatically calculate the other one, which is 0.5. Which is well understood. Okay, so if you are following up to this point, please indicate. Please indicate that you are following up to this point. So right now, you can see that it has calculated its terminal A and terminal B. And if I do my show table for this show table, for this also, now you can see that the molar flow for this, they are correct. It has been split into two. Now, since our temperature here is, if you check the temperature here, you can see that it is 30, uh, um, 63.39. This is still what we have here. This is still what we have here. Also, this is still what we have here. So you can see that our calculations were correct. So if you have any question with regards to what I just did now, please indicate. Ask your question. Okay, I'm waiting for question. If there is none, we can proceed to the next example. Okay, the degree of freedom. Um, Let me give another example. Okay, this is stream one. Now, in stream one, there are things you need to specify. And, okay, you can specify 1, 2, 3, 4, then your composition, 5. These are the things you can specify. Now, there are 5 things here you need to specify. So it means the degree of freedom you have, it is 5 minus 1. If you specify, okay, now your composition is very, very important. If you specify 5, so the degree of freedom is 5 minus 1, which means you need to specify only 4. So if we now look at what and what did we specify? We specified this, we specified this, we specified this, specified composition. Now we can either specify, if you don't know the temperature, you can specify the vapor fraction. But the thing is, you must give as Spe Hysys 4 data. 4 data. I told you the things you need to specify is 1, vapor fraction, 2, temperature, 3, pressure. So you can either specify, um, this is 4. You can either specify the molar flow or the mass flow, whichever one out of these two. So you can see that we specify the molar flow. As Spe Hysys calculated the mass flow. So yeah, sorry, mass flow. We specify mass flow. As Spe Hysys calculated molar flow. Now, if you specify molar flow, Spe Hysys will calculate the mass flow for you. So basically, it's not something you just need to crack your head about or remember all the time. But know that your degree of freedom is the required input minus 1. quite easy, sure. Okay, I believe this area now is well understood. This area is well understood. So we are going to move over to the next example. And the next example, we're going to be taking is a pump. Let's look at the pump. Let me share my screen, which I believe everyone can see my screen. Okay. Now the pump. What is pump used for? Pump is basically used in increasing pressure. And we want to increase the pressure of water from 1 atm to 5 atm. How do we do that? What is our problem statement? First of all, say a pump is used to increase the pressure of water from 1 atm to 5 atm. The inlet temperature is what? 25 degrees C, and the flow rate is 10 kilogram per hour. Determine the work required by the pump. And we still have water. So basically what we are going to do now is still work on this example. So for this, we have um, 63.39. We want to pump terminal A. We want to use a pump, want to add a pump to terminal A. That's basically what we want to do. And terminal A, I'm going to double click on it to see the pressure. Okay, the pressure is 1 bar, which is 100 kPa. 1 bar, which is 100 kPa. So what I just need to do now is to come here and type pump. You can see the pump here. I'll click it and add here. I'm going to also add another one. This one I'll name it pump out. Pump out. So I'll double click on this, specify the inlet stream, which is terminal A, specify the outlet stream, which is pump out. Now you can see that it requires an energy stream. Okay, I'm going to explain that. Whenever you are using your pump or your pumping machine requires energy, requires power, which is light. You need to turn on your gen and use your pumping machine. So that's basically what Spe Hysys is saying. There needs to be an energy stream. There needs to be something that will drive your pump. So I'm going to call this QP or Q100. Now, the moment I do that, it is telling me unknown duty. What it's trying to say is, yes, I know that there is an energy, but I don't know the required energy to drive this pump. So what we can do, our statement says we are moving this from 1 ATM to 5 ATM, or 1 bar to 5 bar. I'm going to come to my worksheet. Now, under my worksheet, there are things we can change. One of the things we can change here, which is what is on blue, we can change the vapor, uh, the vapor. We can manipulate our temperature. we can manipulate the pressure. We can manipulate this molar, molar enthalpy. We can also manipulate molar molar entropy. Okay, or but our question says what we are to manipulate is just our pressure from 1 bar to 5 bar. So for that, I'm going to click on it, pressure, and type 5. Now you can see that Spe Hysys has done what? Has calculated the rest. It's calculated the outlet temperature. It's calculated the molar flow. It's calculated the vapor. There's no vapor. It's calculated every other thing that we are supposed to give because we included the pressure. So you can see from 100 to 500, 5 times. So it means our Spe Hysys also calculated the duty for this pump. You can see now that everything has been totally set. I'm going to move these things backward. Uh, okay. Now, what did our question say? It said determine the work required by the pump. So I'm going to damn. I didn't know. I didn't know the practical screen wasn't showing. So okay, I'm going to do that again. Let's go to let me go back to our Spe Hysys. Okay, so I will delete this whole stuff. I'll delete this whole stuff. Yeah, it means you are following. And who is this person that is following? Yeah. So what we want to do is we want to increase the temperature of want to increase the pressure of pump A. We want to increase the pressure of pump A. So from here you can see that 63.39, 3.39, the same temperature, the same pressure, 100 kPa, 100 kPa, which is kilopascal and equivalent to 1 bar, the same thing as 1 bar. So I'll come here and type pump. You can see this is the pump. I'll click on it, select it, and place it here. Also select this, double click on it, type pump out. You understand? I'll double click on this, specify the input, which is A, specify the output, which is pump. Now it says we require an energy stream, which is what I explained before. You need to specify an energy stream, which is P100, and that's good. It said unknown duty, which is this. See, unknown duty. So you can see now that it's calculating. This is the pump is showing a yellow outline. The pump is showing a yellow outline, which means some of the parameters are not yet specified. So I'm going to click on the pump. Let me be sure that You guys are seeing what I'm doing. Okay, you guys are seeing what you guys are seeing. Okay, now when it says on duty, we have specified the energy stream. We know that yes, this pump requires an energy. You understand? But we don't know the exact amount work or amount of energy needed to drive the pump. So what I'm going to do, I'm going to click on worksheet. Under worksheet, we can see our input, which is terminal A. We can see our output. And I told you in our previous class when all whatever is whatever is written in pure black are things that Spe Hysys has calculated, or are things that you cannot modify. But the other ones on blue are things you can modify. So what we can modify is our pressure, which is 5 bar, which is 5 bar. Now you can see that as Spe Hysys automatically calculates the rest for us. And if we check, this stream is now fully specified. I believe you understand that. Yeah. I'm going to double click on it again. This time I'll click on property, no, conditions, click on parameters. So from here now we can see the duty. So this pump uses 4.0910 kilowatts of energy to drive this at at 75% efficiency. So this pump is 75% efficient. You can see it here. And I'm going to show you something. Now, at 75% efficiency, the output pressure, the output temperature was what? This kilopascal. This is the molar flow. Now, if we change this efficiency to 50%, what is going to happen? Let's see the temperature. You can see the temperature has increased. If this is 10%, temperature has increased. So the lesser the efficiency, the higher the work done by the pump. So for this pump now, you can see that the duty has increased to 30 kilowatts. 30 kilowatts. It has increased to 30 kilowatts based on. So you can see that you just need to specify one. As Spe Hysys does the calculation of the other. So I'm going to leave it at 75. And you can see it's at that you can see that it's at 4. You understand? So if you are following, I would like you to indicate if you are following this class. So if you have any questions so far from the class, I would like you to ask on the comment section. Okay, after that, we are going to take the last example for today. So, but I'm expecting lots of questions from you guys. Okay, so far, so it seems no one has any question. So we are going to move over to the last example and final example for today's class. Um, so what we are going to do now is to use our chiller or cooler, whichever one you want to call it. So I'm going to type cooler here, and this is a cooler. Click on it, then I'll double click on this and name it code string. Code string. So pump out and code string. We also need to specify the energy stream for this. I'm going to just type QC 100. Now it's also giving me a warning, which is unknown delta P, which is unknown change in pressure. But what we are actually doing is I want to cool it down, which is change in temperature. So I'm going to double click on the chiller, come to my worksheet again, come here and change this temperature. Maybe I want to cool it down to 20 degrees Celsius. I'll do that. Then um, what else? What do we need to do again? Okay, then now we also need to specify at what pressure. We also need to calculate the pressure drop, indicate the pressure drop, calculate it. Okay, so I believe you all understood what I just explained from beginning aspects up to this point. I'm expecting lots of questions. Okay. What operations in the oil industry that Spe is used for? Basically, what we did is what we are going to do, or more, yeah, in the oil industry. You're definitely going to use a pump to pump your crude oil from wherever, from terminal A to terminal B. That's basically what you are doing. At some point in time, you will need to cool down a fluid from a high temperature to a low temperature. That's basically what we have done. You will need to split a flow. So what is coming out from is one stream. You want to split it. Maybe one is going to your storage tank, and the other one is going to the export terminal. That's basically what you have done. So whatever we have done here is what is applicable in the oil and gas sector. So I'm waiting for more questions before we call it a day. Okay, so I believe what I explained so far is well understood. Um, More questions concerning this Aspen High, since the paid session is going to be made available in the WhatsApp group. So if you have any other question, I would like you to drop it on the WhatsApp group. Thank you all for participating in tonight's training. We are going to see some other time.